Hey everybody, welcome back to EdPuzzle. We haven't done EdPuzzle in a while. We've been doing a lot of Desmos, but it just depends on what we're doing for the day is the medium by which we learn it. We're going to do patterns today and some translation. This video should be kind of brief, but I'm going to give you some heads up about some things. I'm going to get quieter in a second because I'm going to move over and draw on the smartboard, but I just wanted to prep you and intro the lesson. Hey, here we go. I'm going to put some math expressions on the board, and I'm going to show you what they're equal to. And then after maybe you get a sense for the pattern, then I'm going to start asking questions EdPuzzle style. And if at any point you need to pause and grab a calculator, you're welcome to. Or if you just like to look for patterns first, that's cool too. But remember, you have a pause button, so use it when needed. Here we go. That's the word log. You've seen it already. You kind of know what it's related to math-wise. I'm always going to write it with cursive. Cursive L, cursive O, cursive G. It's the only time I write in cursive ever is I write the word log or I sign my name on something. I use cursive because otherwise it looks like 109. My handwriting is terrible, and I don't want to look like 10G or 109 or whatever. And that's probably the nicest I'm going to write the word log. So after this, I'm probably going to write it faster. Sorry in advance. But log base 3 of 9 is 2. And maybe you knew that from when you were doing the graphic stuff earlier. Maybe you didn't. Likewise, log base 4 of 16 is also 2. And maybe you know why, and maybe you don't, but that's okay. Remember, we're looking for patterns here. If you need, you can throw this in a calculator, log base 3 of 9, if your calculator can handle logs with bases. Not all calculators can. My iPhone cannot. Inspire can. Hey, log base 4 of 16 is going to kick out a 2. And again, maybe you know why. That's great. All right, one more example. I know what you're always thinking it's 2. Log base 2 of 8, though, that's 3. So now it's your turn. Log base 2 of 32 is equal to what? So hopefully you threw it in a calculator and you threw in log base 2 of 32. Maybe you looked it up on the internet. Maybe you used desmos.com/calculator. Whatever. Maybe you found out it was 5. And I'm going to do another one of these and another one. And then maybe we'll talk about the pattern and then maybe we'll do some more. But this is like the hardest thing we're doing all day. Okay. Log base 7 of 49. Take a second, grab a calculator, or try to figure out what the pattern was, how those two numbers are related. And I'm going to go back a screen really fast so you can see them. You had that log set up. 3 and 9 somehow were related and gave you a 2. 4 and 16 were somehow related. It gave you a 2. 2 and 8 were related somehow, and it gave you a 3. Just like 2 and 32 were related somehow, and it gave you a 5. So how are 7 and 49 related somehow? So maybe you said 2. I hope you did. Okay, here's one more before I spoil the fun, reveal the secret. Log base 9 of 1. Try that one in the calculator or see how well you know your log patterns right now. Oh, wait. All right. Hopefully you knew it was 0? Oh, well. So here's how it works. I'm going to jump back a couple slides, and we're going to walk through it. Really what I'm asking on all of these, I don't know where my stuff went, but there we go. Log base 3 of 9 is 2 because this is really asking 3 to the what power is 9? And we know that 3 squared is 9. Likewise, that guy is the same thing as asking 4 to the what power is 16. A logarithm is just an alternative way of looking at an exponent. Whenever you see log base 4 of 16, I hope you're thinking, hey, 4 to the what is 16? Just like, hey, 2 to the what power is 8. A lot of people say 4 because they're thinking like 2 times, but it's not really. It's like, how many times does 2 get multiplied to give you an 8? 2 times 2 times 2. 3. Log base 2 of 32 is 5 because 2 to the 5th is 32. That's not awful. The screen's getting awful though, so there we go. So log base 7 of 49 was 2 because 7 squared is 49. And then the weird one was log base 9 of 1, which is a really nice way of saying, hey, like 9 to the what power is 1? And 9 to the 0 is 1 because anything to the 0 is 1 except for 0 to the 0, but that's like a weird thing, so whatever. But log base like 13 million of 1 is 0 because 13 million to the 0 is 1. So maybe you have the hang of it now, and I'm going to put in another one, and let's see how you do. Log base 5 of 125 is what? Oh, wait. Okay, so maybe you threw this in your calculator. A lot of people struggle early on with choosing LOG with a little base underneath it. Sometimes you just see LOG and there's no base. We're going to talk about that in a minute. But for now, LOG with a base, put a 5 in the base and put 125 in what's called the argument. So this is really asking 5 to the what power is 125. And that's 3. And I'm going to try to write this because a bunch of times so people understand that there's a relationship there. Is this going to get more difficult? Yeah. Is it going to break you? No. This isn't horrible. All right, one more. Let's see how well you do with weird stuff. Log base 7 of 1/7. Hopefully, you're really thinking 7 to the what power is 1/7. Yikes. So I hope you remember negative exponents. Then take the reciprocal of whatever we're talking about and then do something. So 7 to the negative 1 is 1/7. So like that. Like there are worse ones, but not really. Right? We could have done like fractional powers or something like that, but I'll save that for a different day. So I'm going to give you some generalized notes. I'm going to ask a question here and there, and that's okay, but this is like a famous Regents question. In fact, almost every Regents has this in some form. Every Algebra 2 quiz in this unit always has this. The quarter 3 exam is probably going to have this, and you need to know the conversion. Really, I can't write, but whatever. Log base b of n is e. And that's because I'm saying that the b stands for base, and the e stands for exponent, and n just stands for number. And I'm saying that's equivalent to b to the e equals n. Ben. So those two equations are identical. One is in log form and one's in exponential form. And this shouldn't really surprise you after graphing them and seeing that they're inverses, but this is how that works. You could sub in all of the equations we've had previous to this on all the slides, and you'll note that it fits this exact pattern. The equation that I gave you and I waited for versus the because statements I was writing on the right, they all take this kind of form. So, sorry, voice cracking, going through puberty. You have to know the conversion between log form and exponential form. So you're going to see something like 6 cubes, 216. Hey, can you convert that to log form? And you have to know that that's the same thing as log base 6, right? Whatever the base is in the exponent is the base of the log. So if 6 is the base on one, 6 is the base on the other. That's the nice one. Then you got to remember to switch. If 3 is the exponent, it means 3 is going on the outside. And the argument's 216. And just in case you ever don't know, it kind of works like that, like 6 cubed equals 216. In case you ever don't know, you can always check it in your calculator. If you type in 6 cubed in your calculator, it'll spit out 216. If you type in log base 6 of 216, it should say 3. You should have a relationship there between those two equations. Okay. I'm going to give you a caution. I'll do it in red. Caution. Sometimes you just see the word log and there's no base. That happens, right? On my scientific calculator at home, it has log with no base. On my iPhone calculator, it's got log with no base. This happens a lot. And if this does happen to you, like, I don't know, like 100, there's actually a secret base there. And some of these are just so common that we don't even bother writing the base. So if you ever see a log without a base, it is a super secret base of 10. That's why if you just type in log 100, it'll say 2. Why? It's 2 because 10 squared is 100. So if you see a problem like this that says log, I just have bad handwriting, it'll spit out a 2. And that's because of that. I used to do that activity and people would say, hey, it counts the zeros. Just a plain old log of 100 is 2 because there's 2 zeros on it. And log of 10,000 is 4 because, yeah, that's right. In a way, it counts the zeros if you're thinking the scientific notation. But that being said, you are going to get a problem at some point like, hey, can you calculate, please, the value of log of 1,000? And you might think it's really big decimal and kind of intimidating, but you put it in your calculator and you're like, wait, what's the base? Harbinger talked about the base in the EdPuzzle. Remember, it's got a secret base. It's got a base of 10. So log of 1,000 is 3. Because 10 cubed is 1,000. Also caution. You're going to see ln. It's called a natural log. We're not talking about that today, but I don't want you to freak out if you're talking with your cool friends on social media or something about log properties and they get all excited and they're sharing like natural log stuff. And I don't want you to feel left out that you didn't learn it. We're getting to it, just today's not that day. So that's the same thing as, just so I can lay the groundwork for the future, just like log without a base is really secretly base 10, natural log without a base, natural log is considered to have a base. We just write ln of the number e. And you heard that right. He said the number e. E is a special number in math, like pi. Pi is like 3.14159. E is a special number too. It's like 2.7186 or something like that. I don't remember the decimal, but it's between 2 and 3. If you find it in your calculator, good for you. It's not the capital E. It's a lowercase e. It's a special number in math. It means something cool involving exponential growth. We're not dealing with it right now. But if you see ln, it's a kind of a log thing. All the log properties obey that one. Okay. Another caution, because, I'm just cautionary today. If I were to give you a problem like log 4 of something equals like a number, like 2, 3, 4, 10, 2 or 3 or 10 or like 0 or like -5, I don't even know. The argument, this guy right here, is never going to be negative. Not ever. Because 4 to any power, or 5 to any power, or 6 to any power, or 7 to any power, or 8 to any power is never going to be negative. I don't care if you raise 4 to the -3. It's 1 over 64. It's not going to be negative. And that's pretty cool too if you think about it graphically. Because Because if you remember the graph of logarithms that you did on the graphical one, they had a look like that. And the domain was all real numbers bigger than 0. So if you were to graph log base 4 of x, -3 or -10 or -13,000 or 0 isn't part of the domain. So we only have to look at positive numbers when we're dealing with that. That's kind of nice. All right, one last thing about logs and we are done. They're actually useful. So it's not like one of those things we just do to do. It's useful a lot, and I mean like crazy useful. If you take one of my computer science courses, it's nothing but logs for about an entire unit in AP. If I'm dissuading anybody from taking AP computer science right now, don't be freaked out. It's really nice to see logs used in a really cool way. We use it for sorting and searching and for making computers run faster, but we're not doing that today. I'm only going to show you like a useful application. If I gave you an algebra problem like 2 to the x equals 16, and I asked you what x was, I bet you could tell me. I hope you said x is 4, because like 2 to the 4th is 2 times 2 times 2 times 2, which is 16. That's not all. And if I gave you another problem like, hey, what about 3 to the x equals, I don't know, like a third? I bet you would know the answer to that too. I bet you knew that x was -1, because 3 to the -1 is a third. And then maybe, oh my gosh, you forgot your log properties. I mean, no, not you forgot your log, you forgot your exponential properties. And I asked you a really fun question like, hey, I don't know, can you solve for x? 5 to the x is 625, and you're like, oh my gosh, that number's so big, I don't know what to do. Maybe it's 5 cubed. Maybe it's 5 to the 7th. Maybe it's, dude, don't stress. Convert. Log base 5 of 625. Remember, we swapped positions. The 625 comes over to the left. So that equals x. And if you just have an entire expression on one side where it's just numeric, like everything on the left-hand side right now is a number. Log base 5 of 625, you can put that in your calculator, and it will do it for you. This isn't like Desmos where we would graph y equals 5 to the x. And we would also graph y equals 625. And one is like crazy, shoots up really fast. The other one's just this nice horizontal line, and we're looking to see where they cross. That's fun, and you guys are very, very good at that. But this one's just a number, and you can throw that in your calculator, and it's going to spit out 4. So if you get an exponential that's kind of big and you're getting a little nervous, throw it in log form and your calculator can handle it. In fact, this is better because if I ask you a question like that, first off, it's not 6. But I bet you could estimate. In fact, I bet you know that x is between what two numbers? Because I hope you're thinking right now, hey, 2 cubed is 8, and 2 to the 4th is 16. And since 12 is between 8 and 16, I know my answer is between 3 and 4, right? Like, it's in there somewhere. You can kind of approximate it. That's a pain in the neck. I bet, you know what we can do? We can do log form. So instead, log base 2 of 12 is x. You can throw that one in your calculator, and it's going to give you a decimal, and that's okay. Right? Decimals are perfectly fine because it's going to give you a much more precise answer than somewhere between 3 and 4. Likewise, five to the x is 100. I bet you know that if you were to do work on this one, you'd say, 5 squared is 25. And I bet you know that 5 cubed is 125. And if you didn't, you could have figured it out. So you know the answer is between 2 and 3. But I'd rather get a more precise answer. So with the precise answer, we're talking about log base 5 of 100 is x. And whatever you get out of that, I don't know because my calculator's not in front of me. It's probably like 2.8 or something like that. So you're going to be asked, hey, solve for x to the nearest hundredth or the nearest tenth or whatever. I also really like asking, x is between what two numbers? So you could just throw it in the calculator and then just look at the decimal and then, bring it down and bring it up. But the more precise way is using a calculator. So I prefer that. All right, that's it for now. You're going to have homework found on delta math, which is something else you haven't seen in a while. So you've got this, you've got delta math, and then if there's anything else you need to be caught up on, now's a great time for that. So thanks, guys, for being here. Hope you enjoyed EdPuzzle or didn't hate it as much as normal. Harbinger.